Hey guys, let's discuss new problem from system design, new topic in system design, which is called design video streaming platform like Netflix and YouTube. And we will be using some AI feature also into that. So here, do you know that how does Netflix stream videos to 200 million plus users without buffering? And also, how does YouTube know exactly what you will watch next? Right, so today we will design a video streaming platform with AI covering real world architecture, scaling challenges, and what actually breaks into the production. So the requirement, functional requirement will be something like this. Okay, let me remove this. The functional requirement will be user should upload the video, that is the must, right? First you should have video, then only user will watch that. Process and store video, then stream videos globally, search and recommendations, and then resume playback. So it means that this system should store the video, and then means first user can upload the video, then the system should process that video, like use the different compression algorithm, or use the different bitrate, okay, save in different formats, and then we need to stream these videos globally, because we need to serve 200 million plus client, which is there all over the globe. And then he should recommend also the user new video, new movie came, or he's interest movie, okay, and then resume and playback. So non-functional requirement would be same for all system design, like low latency. How much low? So 300 millisecond startup, okay, less than that. High availability means 99.99% time it should be available, the system should available. Massive scale, millions concurrent users, okay. And then adaptive streaming. Now what is adaptive streaming? So adaptive streaming is automatically changes based on video quality, automatically changes based on the user's internet speed and device performance. So playback stays smooth without buffering, okay. If let's say the internet speed goes down from user side, so he should not see that buffering thing, right? So automatically our system will like right now he was watching the movie in 4K, so we will be reduce it, and then we'll show him that 1020, right, 1020 or 40 pixel, that format. And then personalization, so AI driven, that would be okay. So means user has watched one movie, so we should recommend him similar kind of movies, okay. Now architecture, if we see here, there are different components like device, data store, and then processing cluster, CDN, users, API gateway. So we will see one by one these components, okay. So let's discuss it step by step. So the first one is device send the request to API gateway, okay. So but before API gateway, load balancer will come. Load balancer will distribute that request into multiple API gateways, okay. So let's say you open Netflix and play Stranger Things, okay. So now you open Netflix on smart TV, mobile, laptop, different kinds of devices, okay. And then your device send request to your application that show me home page or play Stranger Things, okay. So first the request will go to load balancer. Before request reach API gateway, they will go through a load balancer. So what will be the flow? User will send request to load balancer, and then load balancer will distribute that request to different API gateways. Now load balancer distributes traffic across multiple API gateway instances. For example, if 1 million users open Netflix at the same time, okay, the load balancer spread request across many servers to avoid overload, correct. So benefit, what would be the benefit of this load balancer here? So first, prevent single point of failure, okay. If you have only one API gateway and it will get failed, then your entire system will get crash. And then enable horizontal scaling. You can add multiple load balancers, okay. You can add multiple API gateways as well. Now improve availability. One goes down, so just divert the request to another load balancer or API gateway. Reduce latency also, because now requests are distributed in multiple systems, so it will reduce the latency, okay. You will get the faster response. Now let's talk about the second component, which is the API gateway. So that is your entry point. Entry point is actually a load balancer, but all requests go to API gateway. This handles authentication, security, and routing to services, right? You can write your authentication and security logic here, so you don't need to write it on microservice level. Okay, now think of like reception desk of Netflix, you can think. Okay, the API gateway responsibilities, so authentication, JWT, OAuth, and rate limiting, okay, which will prevent abuses. We have talked about rate limiting a lot in my earlier videos. Okay, please go through that core concepts of system design videos. Now request routing to services, request aggregation, logging and monitoring, A and B testing. So now here two things are very interesting, which is request aggregation and A/B testing. Now what is that? So let's talk about that. First is request aggregation. Okay, so request aggregation. So what is the problem? Frontend sometimes need data from multiple microservices. Okay, and without aggregation, the client must call many APIs, so that will be slow and complex. Okay, your front-end system requires data from let's say multiple microservices, and if front-end will send request one by one to each services, so it is time taking. Okay, it is complex also, and slow also, right? So API gateway, what is the solution? API gateway call multiple services and combine response. Okay, request aggregation into one response. So now now from user you will have a multiple request, but from API gateway side he will combine the response and send it to user. User open Netflix homepage, so front end needs first what you want. You want user profile, you want recommendations, okay, you want movie list. So all these three things are calling it's equivalent services. Like for user profile you are calling user service, for recommendations you are calling recommendation service, and then catalog service. Okay, without aggregation front end will send request one by one to each service, but with aggregation front end will send request to API gateway, and API gateway will send request to all three services and then combine the response and send it to front end. This keeps microservices simple and centralized. Now A/B testing. What is A/B testing? So this is experimentation, okay, from Netflix side. So which kind of experiment? See, what is the purpose here? Show different version of feature to different users and compare performances. Okay, so now we will, for different user we will see different features, and then whatever response we are getting we will track that response, okay, and compare the performance. So used for UI experiments, recommendation algorithm testing, right? And then pricing experiments, feature rollout. So for example, you want to test new recommendation algorithm. Okay, so API gateway logic, 10% user you are sending new recommendation service, and for 90% you are sending old recommendation service. Now user will send request to API gateway, and API gateway if that request goes to bucket A, okay, so old recommendation it will show, otherwise new recommendation. So and then using that what Netflix will measure or monitor, he will measure the click rate, watch time, and engagement. Okay, how many users clicked the new one and old one, then how many watched that, and then how many engaged that. Okay, so whichever performs better, roll out to all users that feature or that algorithm. So real Netflix style example if we take, so user 1 you are showing old UI, okay, group A. User 2 is in group B and you are showing them to new UI. So now they will compare that which UI user watch more or which UI user clicks more. Now third one is microservice layer. So microservice layer, you API gateway calls multiple services. Like first one is user service. Okay, so that will store information of user, like who are you, your profile, your watch history. Okay, and then recommendation service, so what you may like or personalized rows. After that, catalog service, which will have the movie list and all the metadata about the movie. Okay, so now fourth component is data store. So currently we are talking about the components of the system. Okay, the first one we have talked about. Means not the components, actually the points. So first one we talk about the normal this thing, what we wanted to design, and then second your functional non-functional requirement. Third one is your architecture. Okay, and then in that architecture the first component was your load balancer or API gateway, and then second was your microservice layer. Okay, So here numbering is different, you can check that. The third one is now data storage. So data storage, here we will store data. Okay, Netflix stores user data, movie and show metadata, and analytics data. Okay, so now you have different kinds of data. So for example, you watch one series Breaking Bad, okay, or Narcos or Money Heist. So that kind of information will get stored in Netflix. Now there are different types of databases, different types of storage. We'll talk about that later. Like first one you will use for the metadata, second one you will use for the storing the large objects, okay, like S3 or something you will use. So now next is processing cluster, or you can say this is the brain of Netflix, okay, brain of Netflix. So here we will use the AI/ML concept. So AI/ML runs here. So personalization engine. Okay, so top picks for you or continue watching. These things will come into the this first one, personalization engine. Second is recommendation algorithm. So in recommendation algorithm, user who watch Narcos also watch Stranger Things. So he will find something like this kind of a similarity using the algorithm, and then will show that to user. So we'll discuss this in detail. Okay. Now um, next is content delivery layer, okay, CDN layer. So before sending videos to you, okay, what Netflix do in backend, he will transcode the video. What is the transcode of the video? So let's say a user has uploaded the raw file. Now that video he will transcode in multiple formats, okay, like 240 pixel, 480, 720, and this 4K by adaptive streaming. For the adaptive streaming, what is adaptive streaming? Based on internet speed. So for example, I'm watching one video in 4K. Now there is some network issue from my side, so my internet speed goes down. Okay, so now he will, instead of showing me that buffering symbol, okay, or instead of buffering, he will show me the video in lower quality, okay, lower pixel, so that I can continue watch my movie. And we'll discuss this also in detail. Okay. Now next is multi-level CDN caching. See, multi-level CDN caching means the content distribution, right, happen. You know that you will have one origin server, okay, and then we know that from CDN cluster we user get the data, but that CDN cluster also divided into multiple layers. So for example, one after origin storage, the data goes to regional CDN, and this regional CDN will divided into further more levels, that is the edge CDN, okay, so edge servers we call them. So first user will request the data, we will search that in the HCDN. If it is there, then we will send him. If it is missed, then in that case he will go and check in regional CDN. If it is not there also, he will go to origin storage, and then only he will get the data. So user request video, HCDN check first, okay, if cache miss then regional CDN, if miss then origin storage, and then response cached back to in all this region and regional, and then edge CDNs. Now what is the benefit? Ultra low latency, definitely, okay. User don't need to go directly to origin server, he will get that from here only, and that to the fast memories, okay, like Redis or in memories. Now reduce load on origin server, okay, and then better scalability and handle viral traffic spikes. Okay, now next is optimized video stream user. Okay, so finally best quality selected for you, then send to your device, and then video starts playing. So the full flow, if we talk about, this is something like this. Okay, first user will send the request from device. It will go to load balancer or API gateway, then from there it will go to microservices, and then that data also goes to data plus AI layer, where the ML model will run, okay, recommendation services for you that will run, and after that he will transcode the video in multiple formats, okay, and then send it to CDN, and then only user will get the data again from the nearest edge location. Real example walkthrough if you talk about, so app request homepage, API gateway authenticated first, then recommendation service generate suggestions, you click Stranger Things, then again video fetched from CDN, Netflix choose 720 pixel based on your internet speed, and then streaming starts instantly. So this is the flow when you watch movie on Netflix. Why this architecture is very powerful? See, we are using here microservices. So microservices itself is a independent scaling, right? You can deploy them independently. You can use any language. So you know all those things. Now AI recommendations. So here they are the personalized recommendations. Okay, each user will get their own personalized recommendations according to his watch history and all. Now CDN will provide you low latency. Okay, user will have a good experience. And then transcoding, so adaptive streaming. Okay, he will not face any issue regarding buffering or this kind of things. And then massive scaling, so tomorrow if more number of users added into your application, then also this is millions of users he can cater. Now Netflix uses microservices, AI recommendations, CDN based streaming, adaptive bitrate to deliver personalized video content at a global scale. Okay, this is the adaptive bitrate. This is, we have discussed many times. And now video upload and processing pipeline. So here video, when someone upload the video, okay, so what is the background of that, what happened with that video later? So first video will so flow will be something like this. First chunk upload. Okay, it is not uploading in the entire video. First chunk will get uploaded, and store raw videos, trigger async pipeline via Kafka. So now here processing will happen. First you upload the video, it will divide it into the chunks and then send those chunks to Kafka for the further process. Now further process, what will happen, and you know that Kafka is a async process. So multiple videos can parallelly, chunk of the videos can parallelly we can process. Now what is there in the processing? So first we transcode that video, okay, in a different formats, and then means one video we will make that we will convert that to 240 pixel, then same video we will convert them to 4K as well, okay, quality. Then you will compress that, you know, different compression algorithm, right, to compress the video, to store the size and all. So next is thumbnail generation also. This is very important because thumbnail is the one which is very important for any video series or something, because this is the first layer where the user will see. If he find it attractive, then only he will click on that video, right? So Netflix also generate thumbnails for the videos, and not only one thumbnail. He generates multiple thumbnails, okay, and then he show these thumbnails to different group of users, and then on the background he will check that which thumbnail is performing nicely, like how many which thumbnail is getting the more clicks, and then according to that he will choose the thumbnail for the video further. Now here you can use AI. So here this is the first AI thing we are using in our system, which is called smart encoding. Okay, so when you are transcoding the video, that time instead of fixing encoding, okay, each and every video will get transcoded into these many formats. No, see, AI will decide which resolution to generate and compression level as well. Okay, so low popularity video, see, if that is the not lots of people are watching that video, so no need to convert it for the full pixels, right? So there you can have a fewer formats, but if it is a viral video, then pre-generated all formats, okay. So what it will do, it will save your storage, okay, and then your compute cost as well. So now next is the storage layer. So storage layer, example data model. So if we talk about the tables here, so the first table you can have the user watch history, okay, where you will have a user ID, video ID, definitely what user has watched, and then his watch time, whether he has completed it or not, or timestamp. Second one will be your video metadata table, okay, where all the video information will get stored instead of the video, actual video, okay. Actual video will get stored in S3 or somewhere else on cloud. So videos, so video ID, title, duration, category, upload time, popularity score, these things will be there in video metadata table, okay. So it usually stores video chunks and metadata. This is what I was talking about, okay. So video chunks means actual video files, and metadata means video title, tag, description, etc. So large video are not stored in database, they stored in the object storage, like Amazon S3, Google Cloud Storage, and Azure Blob Storage, okay. Why? Because object handles you because they handle huge files, cheap storage, highly scalable and distributed. That is the main thing, right? So for example, you uploaded a video like systemdesign.mp4, which is of 1 GB size. Now that system store the chunks like for video 123 he will have a 3 different chunk 123, and later he will merge this chunk or stream directly these chunks to user. Now metadata table. So metadata table, if you talk, that they stored information about the video. This is what we just discussed, okay, like video id, title, tags, uploaded by user, duration. Okay, so here this one will get stored either in SQL, okay, where we will use MySQL or Postgres, or you will store in NoSQL like DynamoDB or MongoDB. So why is this design? Because see, we are storing videos or actual video file in the object storage, okay, like Amazon S3 or something, and then the video information metadata in the SQL or NoSQL. Okay, so scale of billions of videos, fast metadata search, cheap storage, easy CDN integration and fault tolerance. So these are the design works. Now second AI feature we are using is the intelligent storage tiering. Okay, so now here instead of storing in one kind of tier, you can have multiple kind of tier. For example, if it is a hot video, then store in a fast storage. Okay, and if it is a old video, then store in a cold storage. Different types of storage, so it will reduce the cost massively. Now CDN, let's talk about CDN, content delivery network. So this is the critical component for this video streaming platform. Okay, so CDN example is Cloudflare, Akamai Technologies. Okay, so now flow is user request video, CDN serve cached version, and if missed then fetch from origin. Very simple, right? Now third one is predictive caching here. So this is the AI feature we will use, like instead of normal caching, okay, AI predicts which video will go viral and preload them into the CDN earlier only. So for example, trending IPL match clip, so definitely lots of people will watch it. So what Netflix will do, it will prefetch these kind of videos globally. Now seventh is video streaming or playback. So adaptive bitrate we talked about here, right? So HLS, DAS, SH- we will use these protocols. So see, player dynamically switches quality, okay, if your Netflix player, okay, so like if it is a poor network, then he will show 240 pixel. If he is a good network, then 1080 pixel. Okay, so here you will use the fourth AI component feature, which is called QoE optimization or quality of experience. Okay, so definitely he will AI monitor the buffering time, network speed and device capability, okay, of the user, and then on that basis he will adjust the bitrate, resolution and preloading. Second is your AI storage. You can see feature store, okay, for AI recommendation. So what he will store there, which kind of feature he will store there. So real recommendation system use a feature store to store ML features. Okay, so what is a feature store? See, I explained many times the ML pipeline. So first user will have the raw data. From that raw data we will extract the feature and we store that feature in a feature store. From there ML model will get the data, okay, will send this features to ML data for the tuning or for the training, and then on basis of that, okay, he will take the action in real life. So real life inference, you can say that. So feature store, real recommendation system use a feature store to store ML features. Example of feature stores like user watch time, preferred genre, okay, then average session length, last clicked category and device type. So this is the pipeline, okay, feature pipeline you can call. So user activity, it will go to Kafka. From Kafka it will go to feature pipeline. From there he will extract the feature and store it in a feature store, and then he will send it to ML model. Now what is the benefit? So faster real-time recommendations, and then consistent training and inference data, and then reduced latency as well. Now recommendation system, if you talk about, so input data for the recommendation system will be like watch history, clicks, watch time and likes. Okay, so model we will be using here collaborative filtering model and deep learning ranking. Now what is these two models? So let's discuss one by one both. So the first one is collaborative filtering. Okay, so let's say real world YouTube 70% watch video from recommendations only. Okay, so now what is the collaborative filtering? So idea, user who behave similar in the past will like similar content, right? So it doesn't care about video content, only the user behavior. Okay, so collaborative is depending on the user behavior. So for example, if user A has watched Money Heist and Narcos, okay, user B watched Money Heist and Narcos again. So user C, he has watched Money Heist. Okay, so now here he will do the collaboration between these two users, and he will find that A and B both are similar. Okay, and B also watched Stranger Things. Okay, so C, so he will recommend this Stranger Things to C as well, because C also watched the Money Heist similar to B. That's why. Okay, so that's how he will do the collaboration. So here we are not talking about the content, but we are talking about the user behavior. So now we have two types of filtering, so like user based filtering and item based filtering. Okay, now what are the pros? This is very simple, works well with large data, no content understanding needed. Okay, now what is the cons here? Cold start problem. For the new user, you don't have any past history, right? So that is the cold start problem, and then sparse data issue. Second model which we are using is the deep learning ranking model. So this is more advanced AI. Instead of simple similarity, it looks at hundreds of signals. Okay, and that kind of signal will see which kind of signals, and predicts probability you will click or you will watch. So like on the deep learning ranking model, it will give the rank. Okay, so like for example, if the input is something like this, what is the user age, device type, okay, watch time, time of the day, here he is usually watch, and general preferences, recent search, and then scrolling behavior. Okay, so using this input data, what model will predict what is the probability of clicking Stranger Thing, what will be the probability of clicking Narcos, what will be the probability for clicking any documentary. Okay, he will find the, and he will give some score to each probability, and then will rank them. Stranger Thing will come first, then Narcos, then documentary. Okay, so and then he will recommend this these recommendations to user according to this ranking. How deep learning works here? So see, neural network learns pattern, and what kind of patterns? Like night. Okay, so at night user is watching thriller more, thriller series or movies, and then mobile. So on mobile he is watching shorter video. Okay, weekend he is watching movies. So he will find about the behavior of the user. So now what is the pros here? Highly personalized. Okay, for each user it will be different, and then handle complex patterns, better ranking accuracy. So now here what is the cons? Cons will be this one, definitely it is expensive to train. Okay, complex infrastructure and needs lots of data. Real example, if we talk about, so you open Netflix. Okay, collaborative filtering, find the similar users, generate 200 movies, deep learning rank them, and top personalized rows shown to you. Now collaborative filtering finds similar user or item, while deep learning ranking predicts click probability and order recommendations. This is the difference into both. Now here what AI feature you can use, you can add real-time personalization. So homepage changes per user, dynamic ranking, and context aware. Okay, based on the time, device, and mood of the user. Now ninth one is search system. Okay, so here when user is searching something in the search bar, so we will use their Elasticsearch like indexing. What is Elasticsearch like indexing? So it means using search engine such as Elasticsearch that indexes data for fast search. Okay, how Elasticsearch is working? See, instead of scanning complete database row by row, it creates optimized search indexes. Okay, something like this, like search engine built an inverted index. You can say see, we are not storing that Kafka on first. Let's say you have multiple pages, and in those pages how many times Kafka is written, we are not storing that. We are not storing key first page the Kafka is coming 10 times, for second page it is coming on this many times. Okay, What we will store, that Kafka is coming on first and third page, system is coming on first page, okay, design is coming on first page, AI is second page, streaming third page. He is giving some ranking to these words, okay, and then so when user searches Kafka, instantly return first and third page instead of searching entire all pages, okay. So no full DB scan needed. This is the best thing, and that's why it is very fast. Why use Elasticsearch like indexing? So it's a millisecond search, very fast. Now full text search or partial text search also, right? And then auto suggestions, ranking relevance, and then typo tolerance. What is typo tolerance here? That's instead of Kafka you have written KAFK, so still he will find Kafka. So typo tolerance is there. Now what AI feature you can use here? Semantic search. What is semantic search? Instead of keyword search, user type funny dog video, so AI will understand the intent that show relevant content, okay. Now scaling challenges. Now what challenges we will have when you will have a multiple users, okay, multiple users are using your application. So millions watching same time, okay. If everybody is watching at the same time, so what could be the solution? You can put that into the CDN, and then AI pre-warming, okay. AI will predict which content will go viral, and then he will load that content in cache or in CDN, okay, earlier itself. Now sudden traffic spikes, so what is the solution? Auto scaling and load balancing, okay. Slow network, then adaptive streaming and AI QoE tuning, we have already talked about, okay. Quality of experience. Storage explosion, what if suddenly lots of user came? So in that case you use the proper AI compression, okay, where you will store that, okay. You need to store that data, so there will be a storage explosion, okay. So in that case you just use some compression algorithms or tiered storage like hot, warm, cold, okay. Different kinds of tiers you can use there. Now analytics event pipeline, if we talk about here, we know that analytics engine is also going on, right, with recommendation engines. So what analytics engine will do? See, the player continuously send user interaction events to this analytics engine, okay. Events like player has player pause, okay, play, pause, seek, watch time, buffering, completion. So these analytics engine, okay, used for, means these events we will use in recommendation training, QoE monitoring, trending videos, business analytics, okay, all these things. So let's talk about trade-offs here. We are using all these features, but what things we need to sacrifice? So here, if you're going with high quality video, then definitely the cost would be higher. If you're using AI models, then there would be some latency and infra cost, right? We are going here for CDN caching. So cache invalidation complexity would be there, okay, which data you need to store in CDN, because CDN capacity is also limited storage, right? Now real-time recommendation, so they will be expensive because we will run that for each user differently. Now if you talk about failure scenarios here, so what could be the failure scenarios here? See, CDN failure, okay, CDN itself will go down, then fallback to origin, all requests will go to origin, then in that case processing failure, so retry mechanism add there. Recommendation service down, in that case fallback to trending videos, okay. Region outages, then multi-region failover, okay. So store your we just saw that you will have a CDN, then you will have a regional CDN, then edge CDN, and after that you will have a you will send that content to user. So just if regional is failing, then go to different region, okay. Now multi-region design, here we are talking about this one. So replicate videos globally and route to nearest region, okay. Improves latency and availability. Now geo-based traffic routing. What is geo-based routing? Users are routed to nearest region using the GeoDNS. So for example, if user the request will go to GeoDNS, and GeoDNS will find the nearest region, and then that nearest region CDN, he will send the request, and then user can play the video. And then example, just like for Indian user, Mumbai region, and for US region, Virginia region is nearer, right? What is the benefit? Lower latency, high availability, and disaster recovery. Playback architecture. So the next is playback architecture. So what happens when user click on play? See, when user clicks play, the system does not send the whole video. Okay, it will not send complete video. Instead, it will send segment based streaming with manifest file. Now what is there in the manifest file? Manifest file HLS and DASH. This is the protocol. Okay, so player first download manifest file that contains available video qualities, segment URLs and bitrate info. All these info will be there. For example, for qualities you will have that we have these much qualities. Okay, these many qualities video we have 240 pixel, 480, 720, and you will have these all segments. Okay, segment 1, 2, 3. He will not download complete video at first. Segments he will download, and then protocol, which protocol you are using, HLS or DASH. Okay, and then you will have a segment based streaming. So segment based streaming, instead of full video is split into small segments. Like for 10-minute video you will have 3 segments, let's say. Okay, so what is the benefit? Faster start, adaptive bitrate and less buffering. Now what is the this is the flow. Okay, so first you will download the manifest file, then it will select the initial bitrate based on your network. Okay, what is the network bandwidth you have, and then download segments, measure bandwidth and switch quality if needed, otherwise download next segment. So this is how the background working when user clicks on play button. Okay, now player buffer strategy. So player download multiple segments before playback. Okay, so flow, download segment 1 and buffer for next 3 segments. Start playback, continue prefetching. Okay, if network slow, then he will reduce the bitrate and increase buffer size. This reduces buffering and improves quality of experience. So when, let's say I am watching one video and I told you that I will not get entire video at once, I will get the segments. Okay, so currently I am on segment 1, so it will prefetch next 2-3 segments. Okay, so that I don't need to have a bad user experience and don't see that buffer button and all. Now 15th is control plane versus data plane. So see, modern streaming system separate control plane and data plane. What is control plane? Which handles metadata, recommendations, search, user profile and playback history. Okay, so a small request, these are a small request. Example flow, user open Netflix, so fetch homepage and recommendations. So these small thing will come into the control plane. Now what comes into the data plane? Heavy videos, you can say. Okay, heavy video traffic like CDN, video segment, streaming delivery, adaptive bitrate, all these things will come into the data plane. User clicks play, video served from CDN, segment streamed. Okay, these things will come from served from data plane. So why we have separated it? Because the requirement is separate for both, for control plane and data plane. See, for control plane it scales independently. Okay, and data plane optimized for bandwidth, because we are dealing there with the heavy videos traffic, right? Then better reliability and reduced latency. Key metrics if we talk about here to measure streaming performance, see, startup latency should be lower. So it means that time to click play and video start. So between these two things, the time should be lower, like less than 300 millisecond. Okay, buffer ratio, percentage of time user sees buffering, target less than 1%. I don't need to see that buffer and all. CDN hit ratio, so it should be greater than 95%. Everything should come from CDN itself. He doesn't need to go to origin server and then take there, because it will increase the latency. Now rebuffering event per hour, it should be less than 0.5 per hour. Okay, bitrate switch frequency, so how often quality changes. Too high means unstable experience, so it should not change. Now bonus AI features, what we can add here. So auto thumbnail generation. Okay, this is what I told you, that it will create, let's say, 10 thumbnails and will show that to a different group of users, and then will monitor which one is getting more clicks. Content moderation, so it will detect NSFW or copyright contents. Okay, NSFW is not safe for work or inappropriate or sensitive contents. Now video summarization, so short preview for the video like reels, so that also we can use using the AI. Voice to text captions, so auto subtitles you can have. Okay, you don't need to add the subtitle file or something, SRT files. Now, a modern video streaming platform is not just about serving video, it is about optimizing cost, performances, and user experience using AI at every layer. Okay, from encoding to caching to recommendations. So that's it. Thank you.